Hi, in this example I want to demonstrate the solution to a problem that you're probably already familiar with, and that is keeping track of student grades. So I use a spreadsheet instead of the traditional green spiral bound grade book, and I'm going to pretend that it's near the end of the semester, that all my grades have been entered into the spreadsheet, and I'm going to show you how I would calculate a weighted average and how I would then let the spreadsheet assign a letter grade based upon that weighted average. So in order to do this, I'm going to need to use several functions. Okay, so one of the functions that I'm going to use is called COUNTIF, which will allow me to count the number of patterns that occur within a certain range. So it'll look at a certain range of cells and count the occurrences of a particular pattern, return an integer value that corresponds with the number of times that pattern occurs. I'll also use a function called COUNTA, which also looks at a range of cells but returns an integer value that corresponds with the number of non-blank cells. So if any of the cells are empty, they don't get included in the count or the integer value that's returned. I'll use a VLOOKUP function, which we have seen in a previous example, and I'll use the VLOOKUP function to determine which letter grade to assign. It will have to monitor the values in the column immediately to the left and make the determination on the based upon the adjacent cell as to what letter grade to assign. So the VLOOKUP function will be assigned to the cells down column K. I'm also going to need to use either the max or min function, and I show you the max function over here, but the min function is going to work the same way. In fact, I should explain a little bit here. I've put in a text box, just embedded it right in this spreadsheet example, so that you could see the general format of the different functions that I'm going to use. And I tell you what the function does. I also show you again the general format. So if you know what the function does and you know in general how the function is to be constructed, you can apply it to this example, and you can apply it to a number of other examples that you encounter in your real world experiences. So that's the trick in learning to use a spreadsheet, is to become familiar with the tools that you have available, functions being an example of a tool that you have available, and then being able to recognize when that tool is appropriate for solving problems that you'll encounter into the future. All right, I've also put some call outs in here to add some additional clarity and detail to what's going on, and so you might take a moment and read those. I should also tell you that I have a lookup table, and it includes all the cells that are being pointed at right here. So it's really difficult to read this, but I would say that must be about L16. See if I can get to that. That would be L16 through M20. So L16 through M20, those are the cells that are in my lookup table. And I point that out, and I've colorized it because I want you to know that although it might appear that this is part of the lookup table, it is not. This is just a column adjacent to my lookup table that provides some additional information that's useful to the user. All right, so let's take a look at what's going on here. Pretend that I have the students that I've highlighted in my class, that I've recorded their grades over the course of the semester. And furthermore, let's pretend that you'll have to stretch your imagination a bit, but let's pretend that I'm a nice guy, and my students, some did fine, and some did poorly on the first quiz. Okay, so poorly, very poorly, right? So some of my students messed up the first quiz, and so I tell them, okay, fine. If you want to take another comparable quiz, then what I'll do is throw out the lowest of the two quiz scores. So I only count the higher of the two. I'm going to do this on a one-time basis. You're not familiar with, the way I teach, the way I test, and so forth. So what I'll do is give you a second quiz 1. So we'll call the first one quiz 1A, and we'll call the second one quiz 1B. And I'll only count the highest one when I calculate the average. So when it comes time to actually compute grades, I want to compute the final average as a weighted average, weighting the test at 60% and the project and everything else at 40%. So how would that look? Well, if I click on this cell and examine what's in the formula bar here, you'll see that there are two components to the grade. Okay, there's a component that appears over here on the left within nested parentheses that calculates the average of the quizzes and weights that average at 40%. And then I also have a second part of it, okay, contained within these nested parentheses, that find the average of the test. That's more straightforward to see. So I have test in cells H4 and I4 in this case. I add them up, so we follow the normal order of operations that you're familiar with from algebra. And that's done in the first set of parentheses. So even though addition and subtraction wouldn't normally be performed ahead of multiplication, by putting them inside of parentheses, and more specifically by putting them inside of the interior set of nested parentheses, it forces that addition operation to be performed first. So it adds up the test scores, and then in the second set of parentheses it takes that sum and divides by the number of tests in this case, which would be 2, and gives me the arithmetic average. And then, since I want to do a weighted average, I multiply through by my weighting factor 0.6, and that weights the average of the test at 60%. So that 60% will be added to, there's the addition, to this 40%. Okay, and I calculate the average of the quizzes and projects in a similar way, but weight them at 40%, 0.4. Now, what's a little tricky here is that embedded in this calculation is a function, and that's a perfectly legal thing to do. So if in the course of doing a calculation I need to perform a complex computation that I really don't want to have to write the algebraic expression for myself, I can just simply invoke a function, and whatever value it returns, then that'll be plugged into that part of the expression. And in this case, you realize that I've told the class that I'm going to drop the lowest of the test scores, okay, or I'm sorry, the lowest of the quiz 1 scores. Now, if you look at quiz 1, the number of quizzes and projects, that would be the way to say it. If I look at the number of quizzes and projects, there's a total of 1, 2, 3, 4, 5 columns that are storing quiz and project scores. But I made a deal with the class. I said I'm going to drop either the score that you have in column C or the score that you have in column D. I'm going to drop the one that's the lowest and only use the higher of the two in that final computation. So this is where the min function kicks in. So what I do is I add up, and you can inspect this as closely as you want, but I add up all the quiz and project scores. I add up all 5 scores. Then I also subtract out the min of the scores in the range of, in this case, C4, D4. So I subtract out the minimum after adding it in. Subtraction is the inverse operation. I subtract out the minimum, thereby leaving only the higher of the two scores in the final sum. And then when I divide by 4 as opposed to 5, I find the average of the highest scores of the Quiz 2, Project 1, Project 2 scores plus the highest of the Quiz 1 scores. So you can look at that algebraic expression. I think it's pretty straightforward. But again, basically, in that interior set of parentheses, I add up all the quiz and project scores. Then I use my min function to subtract out, to immediately, within that interior set of parentheses, to immediately subtract out the lower of the scores in columns C and D. And I'm left with, in computing that sum within the interior set of parentheses, just the higher of the two scores here being added to the scores in columns E, F, and G. All right, so I'll leave that there for just a moment for you to inspect. But I'm using a function to calculate a weighted average. I'm embedding a function in the formula that calculates a weighted average, would be the way to say it. All right, so once that is inserted, then I can drag down, because I didn't put dollar signs ahead of any of the row coordinates, and I want to apply that basic computation to each of the cells down this column. So when I copy, it copies it the same way into row 5, except that it adjusts the row coordinates to reflect row 5, then row 6, and row 7, and so forth. All right, so there's the calculation of the weighted average. Once the weighted average is determined, then I want to assign a letter grade. Now, I could inspect this score and assign a D based upon my scale that's advertised in my syllabus, where 90 to 100's an A, 80 to 89's a B, and so on and so forth. Or I could let the spreadsheet make that determination for me. And in this case, I am going to let the spreadsheet do it, and I'm going to use a VLOOKUP function. Okay, so we've seen this done before. Excuse me. So how's this going to work? It's going to, if we look at the VLOOKUP function, has 3 parts. You can read the details down here. First part is the cell to be monitored. So this cell, the cell K4, contains the VLOOKUP function. It's going to, in the first argument, refer to the value in cell J4. That's the cell that it's watching. Then it compares that value to the index column of the lookup table. If you look at the second argument, that's the absolute address of the lookup table. So it compares this value that's watching to the index values down this column, and in this case it finds the best fit right here and returns a D. So you're familiar with how the lookup table works. I think it's sufficient just to point out that it's going to be returning values from column D. You'll notice the displacement values too. It's going to be returning values from the second column, and it's going to be comparing the value that is the weighted average, which is the value down column J. It's going to be comparing those column J values to the indices that appear in the table. Okay, so that should be straightforward enough, having viewed the previous video where I went into a little more detail with that. All right, so that's how we assign letter grades. In this case, it's not the only way to do it, but it's a way of doing it, shall we say. And then to finish this spreadsheet off, we have to look at what this frequency value means. Okay, so that frequency value of 12.5 is telling me that in the range of cells K4 through K11, K4 through K11, in that range of cells, the value F occurs 12.5% of the time. D occurs 12.5%. C occurs 12.5%. B occurs 25% of the time. So there's more B's than there are D's and F's. So we have one D, one F, 1, 2 B's. Okay, and it also tells me that in that range of cells, A's occur 37.5% of the time. There are 3 A's. Now, how do they do that calculation? Well, in general, I take the number of times that this particular value, this F, the number of times it occurs in this range, and divide it by the total number of items in the range. So we have 1, 2, 3, 4, 5, 6, 7, 8. If I divide 1 by 8, I get 0.125, and then if I multiply through by 100, I can express that as a percentage. So the way that I determine how many times the letter grade D appears is by checking this range for the number of times that this pattern appears. And there is a function that will do that. If we come over here and look at the COUNTIF function, the way it works is we use the keyword COUNTIF, call it the function by its name, and then it has 2 arguments. We tell it the range to inspect, and we also tell it the pattern to look for. So when I apply that function to this cell, I want to tell it to look at the range K4 through K11, and furthermore, I want it to look for the pattern that it sees immediately over here to the left of itself, the pattern that it finds in cell M16. When I calculate this value, I want the spreadsheet to count the number of occurrences that this D value, which appears in cell M17, appears. How many times does it appear in this range? So again, COUNTIF, if I say the range is K4 through K11, and if I have it inspect for the value that is in cell M17, it'll return a value of 1. So the COUNTIF function is always going to look at, it's going to be applied in here in combination with COUNTA, but it's going to be applied in here. It's always going to look at, whenever it's applied, it's always going to look at the cell immediately to the left and see how many times it appears in the range K4 through K11. Now that will tell me the number of times that pattern occurs. That's going to be my numerator, or if I think of it in terms of division, that's going to be my dividend, and then my divisor is going to be the number of total total grades that occur. And so the number of non-blank cells in the range of K4 through K11, however many there are, that could be used as my divisor, and that's what COUNTA does. If I use the COUNTA function and give it a range, it'll return the number of non-blank cells, which in this case would be 8. So as I look at the specifics here, what I'm going to do is divide the value that COUNTIF provides me. I'm going to divide it by the value that COUNTA provides me, then multiply through by 100. Okay, so specifically here, if I look at this, I want to see how many F's occur in the range of K4 through K11. F is found in M16, so if I go up here, COUNTIF, the range that I want to look at, that's the first thing in COUNTIF, the range I want to inspect. The range I want to inspect is this absolute range, K4 through K11, so I'm using the dollar signs to lock down the row coordinates. My second argument is the pattern that I want to look for. The pattern that I want to look for is the value stored in cell M16. That will return the number of times that the pattern in M16, value being F, the number of times that it occurs in this range. And in this case, it would be 1. And then I divide by, my divisor is going to be the value returned from count A. It's going to look at that same range, and it's going to use absolute cell addressing. And then that would calculate to be 8. So I'd be dividing 1 by 8, and then multiplying through by 100 just to push the decimal place 2 places to the right so that I can express that frequency as a percentage. And once I type that into this cell, then because of the way I have things constructed with the dollar signs, it is possible to drag down. Since there is no dollar sign in front of the row coordinate on the second argument in the COUNTIF function in cell M16, that means that when I drag it down, in the next place that it copies it into, it'll copy it in a relative way and allow that row coordinate to change, thereby looking for the pattern that occurs in cell M17. And finally, to finish this off, I did put in a sum function down here just to verify that among all the possible grades that occur in this range, the grades individually are represented by a percentage that represents the frequency of occurrence. And if I take all those values and add them up, they turn out to be 100. So 100% of everything is accounted for right here. All right, so that is the second video, and from this you should be familiar with the functions that I have outlined here. If you're not, there is information to be found from the Excel help files and also just by doing a Google search. And you should also, from this example, see how a complex algebraic expression can be constructed, and should also then understand that functions can be inserted into formulas in order to simplify things. And then you again saw an example of how VLOOKUP table could be used to assign letter grades. And then in the calculation of this frequency, I divide the value that's returned from the COUNTIF function by the value that's returned from my COUNTA function in order to get a percentage. Okay, that's it. Hi, one of the hazards, I suppose, of doing these recorded lectures is that if I make a mistake, then it stays with me forever. And in fact, there was a mistake in the spreadsheet example that I showed just a moment ago. Because of the data that's stored in the spreadsheet, it didn't really impact the final weighted average, but nevertheless there was a mistake, and maybe you picked up on it. My explanation was correct. It's just that I didn't pick up on it as I was talking in this example that was previously developed. I didn't pick up on the mistake as I was talking, and then when I went back and reviewed the video, I saw it immediately. So let me show you what I'm talking about. When I calculate the weighted average, and that's being done, for instance, in cell J4, I need to drop the lowest of the two quiz 1 scores. Well, for this person, okay, for Larry Fine, the two quiz scores are in cell C4 and D4. And in doing the calculation as I described previously, I would add everything up and then find the minimum score in the range, in this case C4, D4, and subtract it out, okay? And if you look up here in the formula, why I have G4, I have no idea. It should be D4 instead of G4. So again, given the data that I have here, it will not impact the calculated value, but to make this correct, that should be D4, so I'll make an editing change through the formula bar and then click out here, hit the enter key and record that. Again, nothing changes, but now the formula is set to subtract out the minimum value in either cell C4 or D4, and that's what I want. So I'm going to go ahead and drag down here, and again, because of the data that I have in here, I don't think it impacted any of the calculations, or if it did, I didn't pick up on it. But now it's actually constructed the way it should be. So I apologize for that mistake, and hopefully this little epilogue is sufficient to clarify things. Thanks.